dance, and more specifically the art of ballet, has long been the subject of controversy. Many enthusiasts want ballet to be seen as a purely aesthetic art form, feeling that in-depth analysis takes away from the overall appreciation of the beauty of the art. Others, such as doctors and therapists, want ballet dancers to be considered athletes. Some teachers want ballet to be taught in a very traditional way, passed down from one experienced professional to another. There is a growing body of work, though, that is moving towards appreciating and teaching ballet from a more scientific approach. That is to say, scientists feel that understanding the human limitations of physics can help a viewer appreciate and enjoy a performance more. Also, teachers are learning more about and apply more physics, biology, physiology, and psychology of dance along with the aesthetic. For me personally, learning about human growth and development along with physics has enhanced my teaching greatly. The focus of this report was to understand the physics of dance. To do this, I looked at a turn, or pirouette, a turning jump, called a saut de basque, and a non-turning jump, called a grand jeté. Pirouettes are a graceful turn on one leg, sometimes done on the silver dollar-sized tip of a point shoe. Ballet dancers do more than spin like an ice skater, though. A highly seasoned, expert ballet dancer can create the illusion of giving minimal effort to start the turn and then of stopping mid-turn to the front over and over again. With this first step, pirouette, torque force and momentum and how dancers use them to create this sensation of endless turning are examined. Torque force is a force that causes an object to rotate about a pivot point called the axis. There are many different ways to execute a pirouette, but the most common is done on a straight standing leg with the working leg in retiré, or bent at a 90-degree angle with the toe at the knee. The straight standing leg becomes the axis, and the torque force exerted by the dancer against the floor initiates the rotation. The only source of force is from the dancer's contact with the floor. The dancer uses the preparatory positions of the feet and body to exert angular accelerations to produce the turn. Forces that are widely separated and acting on a body produce more torque on the body than forces that are closer together, and they produce more effective rotations. To start a turn, a ballet dancer stands with the legs turned out in one of 5 basic positions. Then the dancer pushes sideways in opposite directions with the 2 feet. The farther apart the feet, the more force a dancer has to work with in achieving the turn. Once the working foot rises off the floor and the supporting foot achieves its full rise, the torque force effectively ends. External torque is the only way a dancer can change the rotational momentum of the turn. In truth, the initial push off the floor of the pirouette is the force that dictates how much momentum will be in the turn. A dancer can give the appearance of adding momentum during the turn by spotting the head, but the laws of physics dictate that they can't add any momentum in relation to the body. One thing they can do, though, is store momentum. If the arms start to rotate before the body does, the dancer can store rotational momentum. This stored momentum can then be transferred to the body and give the dancer more speed in the turn. The next 2 moves, saut de basque and grand jeté, are jumps that involve a run or traveling series of steps as a source of momentum. Since the run or approach to these jumps is often the same, I'm looking at them together initially. In the initial run, it is important for the dancer to flow through the run to gain the maximum velocity and overcome inertia. The dancer wants to achieve maximum equal and opposite force from the floor for forward propulsion. During the approach, it is important then that each running step move back faster than the body is moving forward. Before the takeoff, the dancer must lower the center of gravity using the plie. This increases the time the dancers can exert force upon the floor, increasing the vertical velocity of the jump. From this point, the saut de basque becomes a turn in the air. The experienced dancer will also avoid leaning back as they run, but allow a slight lean back in the moment right before takeoff. If the center of gravity is back during the run, it acts as a braking force. A momentary braking force is necessary at the takeoff point, as this allows the push-off foot to act as an axis around which the body will rotate. As the dancer takes off, the arms and legs fully extend to give the illusion at the height of the jump of stillness. The velocity of the leap would decrease as the dancer rose into the air, achieve a moment of no vertical motion, and then descend with acceleration. An experienced dancer times the full extension of the arms and legs for that moment when there is no vertical motion. Then on the accelerated descent, snaps the arms and legs close as the soda bus takes its airborne form. This allows the dancer to transfer momentum to the turning body. To land this turning jump, the dancer must distribute the forces of impact. Impact is a function of weight and speed. The dancer's weight does not change, so the speed is then the only variable. To safely disperse the impact, the dancer must spread the force out over time. The dancer fully extends the landing leg to align the joints, then allows only one joint at a time to absorb the shock in a quick succession, toe, ankle, knee, hip, touching down before facing to the front to increase the time and area over which the retarding torque force has effect. A grand jeté is a wonderful jump where dancers get to transfer the momentum of the horizontal approach into the vertical jump. The only difference in the initial approach is that in the moment before takeoff, the dancer would lean slightly forward into the jump, as no braking action is needed to gain torque force. A study done of Australian football players found that in horizontal jumps, large peak displacement of the trunk occurred naturally. The movement of the trunk translated into the direction of the horizontal jump. So someone trying to jump horizontally forward, like a dancer, would move the trunk of the body substantially forward of the center of gravity. As the dancer leaves the ground, they lift their legs into the air to the split position and the arms into the air in a variety of positions. All this helps the dancer raise their center of gravity. With precise timing, the dancer's head and torso will move horizontally while the center of gravity moves near the peak of its curved trajectory. The audience tends to watch a dancer's upper body with the eyes following the head and torso, thus creating the illusion of floating horizontally. It is important to note with jumping that dance, ballet in particular, has evolved the use of a sprung floor. While the spring of the floor does not offer noticeable force for higher jumps, it does help soften the blow of the landings. The give of the floor can substantially increase the time in which the landing takes place, dispersing the impact of that landing. This can be a valuable asset in preventing injuries, as well as a catalyst for dancers pushing themselves to new heights. Learning how dancers use physics has taught me so much about how certain difficult ballet steps are performed. As I started this segment of the class, I began integrating this material into the ballet classes that I teach. While I notice some students' eyes glaze over when I start to talk about physics, if I just talk to them about what they need to do to make the steps work, I see tremendous improvement. It is important to note